Hello everyone, welcome back to the channel. So in today's video we are going to talk about object storage. As discussed in the previous video, it is like Git database where we store the commit, folder structure, file, content like text file, code files, be it in Go or C Sharp, whatever language you are using. This is very fundamentally important to understand because till the time our code is pushed to the online repo, GitHub, GitLab, Bitbucket, wherever we have that repo. Till that time, it is in our local .git folder. So it is very essential to understand how we store it in .git folder. So let's get right into the video without wasting much time. So let's discuss the core concept behind object storage in Git. So first thing is it is content addressable storage. What does it mean? You have this file, it has some content, text content. So according to this text content, a address will be generated. Address will be generated. And using this address, we'll get to this content. That part is understandable. And how we are going to calculate this address is using SHA-1 hash. And what thing we'll hash is the content and the metadata. What will be the content? This text file content. Metadata is header. We'll discuss about it. For the time being, it's a header which states what type of object and size. So what does this ensure? This content addressable storage is integrity, because if you have some file with same content, hash would be same every time. If something wrong with this file, we will able to catch because hash will change and we'll see that with same content hash is something different, so maybe it is corrupted or something. And reduplication means we will have only one copy of this file, not many, only one copy of this file with this content. And we can see we have different types of object. Blob is for file content, tree for directories, folder structure that we have. This is folder, inside this we have two folders, so to store this we use this object type. And the commit, basically the snapshot of the current code we have, whatever changes we have in our project, snapshot of that instance is the commit. Let's discuss the storage structure, how we store in our Git object storage, which is a content addressable storage. So what we do is we create a hash, then we convert it to a hex. And there is one thing, that this SHA-1 hash will always be 20 byte. You can check and read about it that SHA-1 always have 20 byte. So 1 byte will convert to 2 character in hex. So our length will be always 40. The length will always be 40. So what we do is, whatever hash we did, then we converted it to a hex. So let's take example of this. We will have something like this: C D E F 1 2 3 4 dot dot dot. So first two we will take and make a directory, and then other 38 we will use it as a file. So this is followed everywhere around. Let me repeat, hash, we do a hash, which hash, sha1 hash, and convert it to a hex which of 40 length. And what we do, we take first two and remaining 38 we store it as a file. This is a two level directory structure. So let's understand why we are not using plain as in you have objects folder and line by line we are just storing it. So let's just understand. Let's take example to understand this. We have objects directory and we have 1 lakh files under it. So when the system will list down all those files, it will take time. Plus we will have the name of the file, the metadata about the file, which will take another memory to load. Plus if there is a case of searching or looking up for that file, we'll do a linear search. So performance wise it's very bad. You have large number of files, you have to store their metadata. In when you are searching, you have to do a linear search. So if we do a flatline storage, system takes a toll, performance takes the toll of doing the thing, because in small project you won't face that, but let's say a industry grade project, number of files, million lines of code, then think about it. Then this one directory under that thousands lakhs of files, so it will not be much faster. It will create issues like directory listing slow down, because it takes time. When we have thousands of file under one directory, it takes time to load that directory. If we want to look up some file in that directory, it will take time because we will do a linear search. Memory usage, because we need to load the metadata of that file, that also takes memory. So these are some of the things that we'll face when we have a flat storage. So let's understand the benefit of two level storage. So it will reduce the size of directory. So first in the flat line we had one directory with all the files, that directory is objects. But with this two level approach, we'll have directories in this way. So the directory size in itself is reduced. So if we take example of 1 million files, and we'll get 256 directories. How? Because there are 16 characters in hex. So first two, if we take 16, 16, 256 and 1 million files, so we'll get how many directories we have and how many files each directory will have. So you can see we'll have uniform distribution because of the SHA1 hash. You can read about SHA1 hash. I would recommend to see the significance of this, how it handles uniform distribution, more directories so that we have fast lookup instead of one big directory. So yeah, what benefit does two level solution provide is reduce directory size, evenly distributed files, and as a result much faster lookups, because we know we go to this directory and just search for these 4000 files. not just like you have to go every file then we'll check. And that load on the system is much less. We are loading directories, then we go inside the directory, then we load the file, memory is saved and all that thing. So this is what two level storage solution provide us. Now let's take example how object creation works. So let's say we have file with content hello git. So this text file comes under blob. So this is the object type blob. We create the header, basically metadata. And what does it contain? The type and the size. Header is like this, type and size. And we have this. You will understand why we have introduced this. So this is our header, and we add the header to the content. So that is why we introduce this, to have a termination that this is the metadata header and the content hello git. And now what we do is we calculate the hash of this whole and convert it to the hex. Why we convert it to the hex? As we already discussed, to have that two level folder structure. So we have, for example, we have this file name, and what we'll do is we'll have over here I have taken A1 directory, and the file name is this that we have stored. So this is the full path. When we access this path, this is what we'll construct. You can see this was one hex string, we took 2 and the rest 38 as a file and these 2 as a directory. And the content of this file is stored in the compressed form, and we are using zip library zlib. Then we write this compressed file content into this file that we have b2 c3 something 38 characters and 2 characters for directory. So this is how we store the objects. So let's see how we'll read the objects back. So we'll get this hash usually from the branch head to which commit hash it is pointing to. So we'll get the hash. We know the first 2 are the directory and these 38 are the file name. So we'll construct the path, we'll decompress the content, and we will have something like this. Our meta type of the object, the length of the object, and the terminatory, basically this is ASCII for 0. Termination, that this is the metadata, and then this will be the content. So hello git. So header will be blob 11 and content will be hello git. So this is how we'll read the objects back when we are required to do so. There could be a question that why we choose hex instead of any other encoding like base 64, as we are converting bytes to a string, as SHA1 gives us a byte. So first is file system safe. So if you see over here, we have something like this always. But if we had something else and where we had this doesn't work in Windows. To have a uniform working in every operating system, Linux or Windows, this is better. This doesn't contain any special character, just numbers. I think A to F and 0 to 9. These are there in the hex, and it is case insensitive. As you can see, I have taken an example. D and capital this will work. It doesn't behave in another way. Same way it will work. And human readable is, you can see it is easy in copy pasting. Also, if you want to just look at it, you can see what is happening. But if you have something like this 10001, that would be difficult, as in it will be very long. And also this is just 40 length, not much more than that, and this is way longer. And also it doesn't allow special characters. As you can see, if you get the same file structure to online as in your GitHub repo, same thing you can follow over there. Even in your file path in your local system, same thing. So you can see there is no special characters, and character which are allowed are in this range. So it is predictable than any other, I would say. And also it's just 40 length. That is also one benefit. So these are the reason that why we chose hex instead of any other encoding. So let's see how we'll implement writing of the object and reading of the object. So first we declared the types of the object. As we know, blob tree commit, already discussed many times. And we declare a object struct. What it does is it contains the type, the size, the content, and the hash. This is basically to use in our code, not as in much significance, but how we'll access inside our code. And also the object store. This is we define to know where is the directory, object directory inside our .git folder. So whenever we initialize the object store, we'll provide the directory where this object's directory will be present, basically the path. And we have seen how we store the data, basically the file. What we do, we create a header, then add the full content, and then create a hash, then encode it to the hex. So same thing what we are doing over here is creating the header with object type and content, then adding header with the content and creating a hash of that, and then creating a hex, basically converting it to a hex. And we know the reason why. And over here you could be seeing that why we did this. So it's a, over here it's a array, over here we converted it to a slice. That's what encode to string expects. Now we understood how we create the hex. That is the most required thing to store the object. Now let's see how we'll store in the objects directory. We'll get the hash. We first two character will create the directory, and 38 would create the file. And this is, we are creating the content of the file. And what we are doing over here is just basic thing, compressing and writing it to the file. That's it. That's it we are doing. And we just return hash. We'll just see what we do with this hash in other parts, because over here we are just understanding what we are doing to store the object. So let's see how we will read the objects that we stored using write objects method. So first thing what we do is we'll check if hash length is less than 4, because Git allows abbreviating the commits. So let's take example. So we can see we have 3 commits, and we write git show a, it matches with all. Git show ab, again it matches with all. Git show abc, it again matches with all. So the safe minimum, if we want to have this commit 1, is abc1. You see, abc1 is just 1. abc4 commit 2, abc3 sorry, ABC7 commit 3. So this is how we can uniquely identify the commits. So that's why minimum length 4 is there, basically to avoid collisions also. That's why. So we know it is very simple. We just construct the path. What will be the path? Directory, first two character, 38 characters. Then we got the path, we get the data, and what we do, we decompress the data. Till here we decompressed it. Now we extract the header and content. How we can extract? As we know, over here we added this character, it's sky for 0. So now where it went, we divide it in two parts. Using that we get the index basically, and we divide it. Over here you can see we extracted it, and in the header we again split into two with the space according to the space, and if it's not into, it's not a valid header, and what we do is just return it to use in further wherever we are reading it. That's how we have defined the object struct. So we define the type, size, content, hash. So this is the end of the video. I hope this was useful, and if it was, consider subscribing to the channel, liking this video. We covered object storage in Git in quite depth, theory wise, and how to implement in Go. So consider liking this video also and adding a comment what you find good in it or what you find bad in it, and I'll try to include that in the next video. So you have to do what you have to do, so keep grinding guys. See you in the next one. Bye bye.